Okay, this is going to be our part 2 of work and power, and we're going to do this problem here, and I have a little handout so you don't have to copy the problem down. But you do need to do all the work, and when you do the work, you need to write down what we're looking for, the formula, plug everything in, do all the units, make sure you understand how the unit conversions work. Okay, so let's get started. So here's what we're doing. We're going to find work first. What's the formula for work? Force times distance, and they have to be going in the same direction. In this case, we have a motor that's turning like a little pulley, a winch, to raise a heavy weight. If the motor runs at a current and voltage here, and it takes 400 seconds to lift the load of 500 newtons, there's our force, and a distance of 20 meters. So here's our distance and force. If we're lifting a load up, the force is going up from gravity, and our distance is going up and down, so those are parallel, so we're good for those. Plug these two numbers in, multiply on your calculator, and you get Newton meters. And we already know that Newton meters directly converts to joules, so that means our work is 10,000 joules. Okay, now we're going to find power out. And this is kind of the first problem we've seen where we're going to talk about power out versus power in. So we have to think about what is happening at the output side of this. Well, the output side is where we're actually lifting the load. We've got a motor over here with input of our electricity, and output we're doing the load. So our out is where we're lifting the load itself. So we're going to use power out equals work divided by time. Well, this is the work we just found in the previous step where we were lifting the load, 10,000 joules, and here's our 400 seconds of time. Divide on your calculator, and joules per second is watts. You don't have to do any extra conversions, it's watts. Now power in is on the input side. What are we putting into the system? Well, we're putting electricity in. So that's what we're going to use to calculate our power. So the power in comes from the electric motor. Power in equals current times voltage. So current, voltage, plug those in, multiply, and we get amp times volts, which amps times volts is watts. Now to do efficiency, this is the first time we've done efficiency. We know power out and power in, so we're going to use efficiency as power out over power in. Power out is from above where we found it, 25 watts. Power in is 180 watts times 100%. This 100% just changes this number from a decimal to a percentage for us. And we get 13.9% efficiency. We've rounded that up. That's our efficiency. Not a very efficient system. 100% would be a really great system that's working perfectly. This system, we're losing a lot of energy and we're only getting 13% of the electricity we're putting in. Okay, that's it for these calculations.